Hi everyone, we have Ravi Shah, CEO of Spacewalk Automation, and he has been like 8 years in the industry uh, till now. And he had his education in California State University, and then on, he had done a lot of automation work, and he's on his own right now with Spacewalk Automation. Welcome you again, and trying to understand how your early interest was in the robotics and automation, because this is something that I usually ask. Why did you get into robotics and automation?
Okay. So obviously, I did not start out in robotics itself. So initially, after school, I actually wanted to study physics in detail. So that's what I applied for my degree, and then I moved to US, and then physics kind of got boring because it was a lot of just theory and stuff. So I switched to computer engineering, and then from that degree, that study, um, I discovered a lot of cool stuff. So, and also, like, while I was in college, I was going around in a lot of companies, Tesla and JPL, and both of those places are like super hardcore on robotics. So I think the actual machine and interacting with it, and also just getting to learn a lot about the field in general while I was in that area, it kind of just sparked like a lot of interest and curiosity. And then once that happened, I also went to like this robotics conference, and I saw a bunch of different companies. That's where also I met Mark Rabert. He was the CEO of Boston Dynamics at that time. And then feeling inspired, I joined a research program, and then I worked there for almost a year. So working on like a new framework that Amazon was building. It is now called AWS RoboMaker. So it's a cloud platform where people, they develop software for robots for mostly fleet deployment. So it was still new, and we were testing it out, and we were building on top of that platform. So because of that experience, I was able to get a job in automation, working as a firmware engineer for assembly line packaging machines in Southern California. So there I worked for almost over 2.5 years, so nearly 3 years. And while I was there, we were also experimenting with industrial robots. So namely, your universal robot, and they have a bunch of different kind of machines, and we were like they were the company was trying to develop applications using those robots. So at that moment, I figured, this is everywhere. These kind of machines are everywhere. Almost every manufacturing plant that I go to, they have these kind of machines, and they have been around since 1960s. Believe it or not, it is that old. But obviously, they're not as advanced as they were. They're they were not as advanced then as they are now. But every year they keep adding more features, more functionality, to add more precision, more strength. So I just decided, this is going to be around for a very long time. And surprisingly, in India, we don't have any company of that scale, which has a global name, right? We know Fanuc, we know Kuka, we know ABB, but those are all European and Japanese companies. We don't have anyone in India. So I just figured, this is perfect time to just pack my bag and go to India and just
Yeah,
start
I
doing
was
that.
about to ask about why the journey to India. Yeah, please go on.
So,
Yeah.
and at that point, there was also a lot of other things happening in India, like in terms of policies and politics. So obviously, that making India thing was happening, quite loudly, and there's so many startups, in that zone, and there are a lot of now space companies, defense companies, automobile, and they all need these automation machines, and especially these kind of robots that can do heavy lifting in the factories. So I just felt that there was a lot of need, there was a lot of unmet demand for exactly this. So I decided, okay, this is a good time to go and set foot and hopefully change, make some little change in the process. So I came in around mid 2022, and then I just got started. And ever since, I've spent last 3.5 years literally just getting people together, the whole research, and um, then building the whole first prototype out. So it has been quite a lot of struggle, but finally we've achieved like a good version of it, which we can now then take it to the market and hopefully see what the reaction is on
Yeah,
it.
coming to that. So what's the primary goal for spacewalk automation?
One way to think about the whole goal of this company is to make manufacturing easier in India, right? It's not that we lack talent. It's not that we lack raw material. It's not that we lack capital. We have all of that. We just don't have the drive to just create our own manufacturing advantages, right? Having something like this is a manufacturing advantage, right? So countries like Japan and Germany, they build their own. They did not import it from other countries, and it gives them a lot of leverage, right, against any other country, because we're using their technology to build our own manufacturing systems. So if we have control over that layer in our own country, the scale at which we can grow is unimaginable. So my goal as like the whole company was, okay, we are not a robotics company, right? We are an automation company, and we want to make manufacturing easier for companies in India. So if you want to just frame it as a goal, that would be one, that we want to just make manufacturing easy, scalable, as good as we can.
That's great. Yeah. So when it comes to, I mean, there are different layers in this particular thing that you have taken up, right? There is a hardware layer, there's a software layer. So let's start with the hardware. Like how is it going to help the manufacturing in India?
So in terms of hardware, we haven't really done anything new. This technology has been, like I said, it has been around like since '60s. But what we have done is just made it cheaper to manufacture, right? So yes, right now there are a lot of tools. There are a lot of components that we're still importing from our vendors from different places. But I think at some point we can do them at home in India in our own factories, and obviously the price is going to significantly drop, right? So we are banking on the fact that if we make it ourselves, the cost will come down a lot, which will make it easy for small and medium scale companies to adopt these kind of machines and add precision and power to their manufacturing, which they just can't do right now. So think about like the medium tier companies, like obviously the big ones, like really big ones. They don't care about this. They just go uh, find vendors in Europe and Japan, and they just buy these machines and just bring them to their factories, and they're good to go. And the small ones are just too small. They can't afford. They can't even think about buying anything like this. But the middle tier, they're not big enough to import and not small enough to have just given up on it. So there is this middle area where there's a lot of demand, but there is no supply for it. So what we want to do is we want to position ourselves in a way that we can fulfill that demand, that particular um, sector of economy. And so in terms of hardware, our goal is to just kind of cut the cost down as much as possible and make it easy for this middle tier companies to be able to afford advanced robots.
That's an amazing approach. So, I mean, that gives a lot of question in terms of what about the precision. So when we are competing with the hardwares manufactured in Europe and Japan versus the new born mechanisms that you guys are devising, how are we comparing with those qualities?
Precision is like obviously one of the most critical factors of why these machines become like really useful, and obviously that is also one of the main reason why a human can't do what these machines can do, right? We are not replacing jobs. We are just adding something that humans just can't do. So precision obviously is a big part of it. Precision, as for this machine, our goal is almost like up to 1 mm repeatability, but this is just a prototype. Obviously, when we move to the production, we will have better hardware, and it can go up to like up to zero point 0.4 mm repeatability, which is on the same standard as like any big company right now. um, and that is quite quite an achievement in
That's a
terms of
great thing
hardware.
that you have achieved over the prototype itself.
Yeah.
Yeah, that's great. So what are the other unique aspects to what you have done? Like,
So when we started to build this, AI was not a hype back then. Like ChatGPT has not come out. We're still changing Bitcoin. We're still changing crypto. But I already had a plan to build this. And then while we were still doing this, right, the whole AI boom happened. And then slowly, somewhere in the middle, okay, we started reimagining it. Okay, like what would industrial robots look like in age of like where AI is very common? If everything is just AI based, what will industrial robots do in age of AI? So we started thinking, okay, we can't just slap our own AI and just make it work, because we want it to be very versatile. So instead of building pre-built software or pre-built controllers or even the tablets, we decided we'll just give freedom to developers in our country. We'll let them build the AI. We'll let them build the skills the robot needs. So instead of doing a whole bunch of different kind of interface, we're just going to provide a SDK. So
awesome.
SDK,
Yeah.
which is also it's not just the SDK. We also have our an IDE, which is great for simulation, motion planning, writing code, and just seeing the robot actually do what you want to make it do in simulation first, and then obviously deploy to the robot eventually. And because our language of control is Python, you have now access to almost every AI and ML library that you can think of, and you can just get started. So you can build a non-AI product, you can build an AI product, you can build a whole different kind of skills. That was not possible before we did this, because most of the companies, they have their own language, they have their own software stack. Now, the AI researcher sitting somewhere in a lab is not thinking about a specific robot language. They're using C++, they're using Python, they're using other programming languages that are more common. And most companies, they don't offer something in that common language. And we decided, we'll take that approach, we'll make it open as much as possible, and we'll let people build on it. And making Python first SDK just opens door to so many AI and ML features that other platforms just can't provide. So it's a very unique value that we have added to this
That's
machine.
awesome. So you have enabled the manufacturers to manufacture themselves, and you have enabled developers to develop on top of it with an IDE and an SDK. That's awesome, man. So when you demoed it to me, I also saw the digital twin part of it. Like, okay, just give it to me. What is it like?
So the idea is not just for coding, right? It's for visualization. It's for a whole different simulation stuff. So the idea is, obviously not everybody has access to the robot, right? Now, if somebody is building an application for this robot, they don't have access to the robot. So what do you do in that situation? So you want to write application, but you can't run it on a machine. So, and we added that feature in the IDE itself. So by default, the IDE has all the tools that you'll need to deploy or test and deploy any application that you're building. So before you are sure about what you are doing, you write your code, you test your idea on the digital twin that you have on the IDE. So for you first simulate it, and then once you're confident, you have passed all the tests, then you can just send it to the robot, and then you can observe the machine, and you can also observe the digital twin as they do both they follow the same movement, right? So it's just a feedback mechanism, a visual feedback mechanism that just makes it really easy to control and create new applications.
So what you're saying is we don't need this bot to develop anything for that.
Yes, that's precisely right.
Cool. That's cool. You guys should try it out. So, so is it all available online right now? Have you guys
Uh,
published it? Like, what is the roadmap like?
so we haven't published the SDK yet. It's not publicly available, but we are working on it.
So you guys can contact Ravisha to get the access to it.
Yes.
Yeah. So, coming to the mass production, or I would call it as a manufacturing grade
Mm.
uh, of scalability for this, right? So what is the roadmap, and how are you thinking through this? Of course, people could make their own. All of basically they can customize it, and they can do it. But when it comes to spacewalk automation, what is your roadmap towards now that the prototype to the production? What is the plan?
So right now, you see all the metal parts, right? They are either out of CNC cut and or sheet metal. So the whole body is kind of just that right now, and it's great for prototype, but obviously not great for production. We eventually want to shift to casting. So with casting, we have better vibration profile, we have balanced weight, and just the performance is really great, right? And it's also the industry standard. So casting is one of them, and obviously building a lot of guardrails around the software, so people don't just uh, break things out of out of curiosity. So we are putting those guardrails, safety features, and there's a whole host of changes that we have, even just for the machine itself, in terms of feature upgrade. So right now we have all the wires that are exposed, but eventually we want to get the wires inside by improving the design. We also want to harden the electrical system. A lot of our circuits, I mean, at the moment for prototype, it's not perfect, but eventually we want to get to the production level and get it certified for safety standards. So eventually it will be on the same level, as any other competitor. But obviously that is at least 3 to 4 months away. So our pilot program hopefully will start in Q2. So that's when we'll be reaching out to customers and putting them in the factories, and we'll see how the reaction is.
Good luck with that. Yeah. Cool. So, is there anything else that the investors have asked you with respect to this particular uh, business?
So obviously, like
Because they definitely turn tables, turn your thoughts towards something that's more scalable with respect to the business. So, how do you see the business part of it?
so machine sales obviously is like the obvious one. We are also thinking about like how else can we get the machine out to a customer without them having to pay a lot of money up front. So we want to scale up, we want to figure out and explore that angle as well. And there is another layer, which is the software layer itself. So when you buy the machine, right, uh, it may not have all the possible features in that moment, but as the years go by, as many developers pick up and create new skills for the robot, the robot just becomes a commodity, because you bought a dumb robot, it's getting smarter every day without you having to do anything, right? So it's almost an asset that is appreciating. So and that is a good place for us to monetize it. We want to maybe have some kind of little fee that can go along. People import the skills to the robot. There are various angles that we are exploring, still in process, but there's a whole hardware part of it, and there's a separate software layer of it. And eventually want to get to a point where we have an app store where people uh, can create and distribute new skills for the machine, and the customers who have the machine, they can just try out new things. So for example, the robot may not be capable of cutting metal right now, but in maybe a few months, some company or some developer comes up with the code for it and then creates maybe a tool for it, and then the customer, they just download the app, get it started, and now suddenly the machine can cut metals, right? So we want that scalability part of it to come from people outside of us,
Got
right?
it.
So that is one of the main reason why I really want to push the software part front first, because now you are not just, so now we are almost thinking about the progress of the machine like a software company, right? We ship a product, we ship a feature like in every update or on every few major cycles. So it becomes almost as scalable as a software. Although it's a hardware, it becomes as scalable as a software. So that angle is like quite impressive.
That's awesome. I mean, that gives a very nice roadmap to you. Cool. I mean, it was a very nice interview, and I felt I've been noticing your journey for last 2 years, and it is very inspiring. I should tell you that it's more like entering every time I come and meet you guys. It's like entering a nice R&D garage of the future, and we're doing something. And I've seen it from empty tables of this garage to a big machine behind us here. So congratulations on
Thank you
that.
so much.
We'll catch up soon.